So actually, before we go to 2 dimensions, there's a good follow-up question to ask ourselves, right? Before we had the railway car collide to each other, and they now move in synchronous like this, right? Now it is inelastic, which means the kinetic energy is not conserved. So what does that mean? So the initial kinetic energy is not equals to the final kinetic energy, but it's equals to final plus some other energy. Okay. Why do I put other on this side and not this side? Well, ask yourself, is the kinetic energy initial and final, which one is larger? Well, if there's other heat loss, this guy would, in the final state, it will be moving slower than initially, right? So this must be a smaller number, the final. So it must be initially that amount of energy partly went to the velocity, partly went to the motion, and partly went to heat and sound and light and everything else, right? So how much energy is lost? So this is the energy loss. In other words, energy loss in collision. So this is a good question. How much energy is lost? So in this collision, so we can ask, well, the energy loss, we can solve for this. Let's say this is part B. The energy loss is Ki minus Kf, right? It's the change in kinetic energy of that. So we need to calculate the total initial kinetic energy, which is the kinetic energy of A initially. Right, so this guy K, let me just label it, right? Ka initial, Kb initial, and Ka plus B final. Okay, so Ka plus Kb initial minus Ka plus B final. Okay, so we're going to put in the MB squares, half MA UA square. I've defined it before, even though I erased it. Half, now you can put in MB UB square, but since that is at rest, you can just make that 0, or you can just claim that that is 0 right after this step and no need to write this. So let's do that. So you can just write 0 minus 1/2 capital M, right? Now this guy move in synchronous, right? It's together. So it's capital M and the speed v squared. Okay, so we're gonna plug that in. So now we have 1/2 M, which is 10,000. So that's 10 to the power 4. U was 24 meters per second squared minus 1/2 M. What is M now? This is MA plus MB, right? So it's 20,000. So 2 times 10 to the power 4. And V squared, right, is 12. V was 12 meters per second squared, like this. Okay, all right. So you can plug in the numbers, and I believe if I've done it correctly, it's around 1.44 times 10 to the power 6. You can double check this. 10 to the power 6 joules. Okay, so now you put back in the SI units, because everything here is kilograms instead in the MKS units, right? In MKS units, and everything else, joules, is made out of MKS units. So if you start off with MKS, you end up with MKS. So yeah, so that's the amount of joules that is lost, the energy lost to other forms of energy. Okay, so this is a useful thing to calculate as well. And sometimes questions might ask you in inelastic collisions, it's often popular to ask you about that, the energy loss as well.